Okay, so in this video, we are going to talk about two different types of energy. We're going to talk about the kinetic energy, potential energy. In my previous videos, I already mentioned those. And here I'm just going to, bring them together and do some little summary. I'm also going to solve a couple of problems, guys, to show you how to handle these problems on the different types of energies. And so I'm going to start with kinetic energy. So mathematically, kinetic energy is mathematically described as 1/2 mv squared. And it's pretty much if you have a vehicle that has a certain mass and it moves at a certain velocity, so that particular vehicle has a kinetic energy. And again, kinetic energy always associated with the motion of an object. And so as long as this moving vehicle now can cause damage to anything that is surrounding it, that vehicle carries some energy and is able to do some work also. Now, and if you remember, work is nothing else as change in kinetic energy. So what is the potential energy? Now, potential energy also called stored energy, and the potential energy abbreviated is P, and could be found as the mass times the, if we're talking about the potential energy due to gravity or gravitation potential energy, it's m times g times the height of the object. There are other types of potential energy, which also could be stated as a stored energy. For example, if you have a spring and you compress the spring or you stretch the spring, it has some potential energy that can do some work. And I introduced this concept some time before when I was explaining you guys the Newton's second law, when I used the spring to generate a certain force to move some weights. So that when I first stretched that spring, what happened is I created this stored energy, potential energy, and when I let it go now, when it came to its equilibrium, it released the potential energy, and that potential energy turned to the kinetic energy. It moved the object. So in the next part of the chapter, of course, we're going to discuss the concept of conservation of energy, and that's where I'm going to talk about how if you elevate, let's say, a certain object against the gravitation potential energy, and you're going to let it go, so there will be, of course, potential energy will not be destroyed, but it will be converted into kinetic energy. And so I'm going to talk about that in my next video. But in this video, I'm going to solve some problems on these two different types of energies. So what kind of problems now could be presented to you? I'm going to use your textbook problems. They're actually pretty good for this topic. And I am on page here 48 in your textbook. And the problem here, example 3.3. Example 3.3. So let's see what's given here. Find the kinetic energy of a 1,000 kilogram car when its speed is 10 meters per second. All right, so what's given here? Well, first of all, I'm given the mass. And my mass is 1,000 kilograms. It's only one significant figure here. So just pay attention, guys, to significant figures. And its speeds, so the velocity of the vehicle here, 10 meters per second. Now, apparently, which of the two formulas you're going to use, and of course, I have the match of the units of with the first formula. That's a kinetic energy here formula. And another clue that I know which formula to use is that this object is moving initially, and as such, it's energy of motion, which is a kinetic energy. Okay, so I'm going to use the kinetic energy now equal to 1/2 mv squared formula here, and I'm going to just plug in. So the mass is 1,000 kilograms multiplied by 10 meters per second, and of course don't forget to square that because of this square in here. All right, so let me just do the calculations. I mean, I really don't have to use my calculator here because 10 to the power of 2 is 100. 100 times 1,000. So you got 1,000 times 100 here divided by 2. So this will give me here, I just have to add 2 more zeros to the 1,000 and then divide it by 2. So this will give me 10 divided by 2 is 5, and then 1, 2, 3, 4, 1, 2, 3, 4 zeros will be now transferred here. So it's 1, 2, 3, 1, 2, 3, 4, and that would be the units now, the kilograms times meter square over the second square. And of course, we know that this is a unit of joules. 50,000, right? 1, 2, 3. Joules will be now the unit here, measurement. Now, of course, you can convert this 50,000 joules into the kilojoules. So you're going to say that 50,000 joule times 1 kilojoule is 1,000 joules. Same units will cancel. So now the 3 zeros here, 3 zeros will cancel each other, and the final answer will be here 50 kilojoules. So the moving car 1000 having mass of 1,000 kilograms, and with the velocity of 10 meters per second, will generate kinetic energy in the amount of 50,000 joules or 50 kilojoules. Now, what could be the problem now on the potential energy? Well, we can create a problem right here, right now. So again, I'm going to use a problem on the gravitational potential energy here. And let's say now I need to move the same vehicle. I have a mass here of 1,000 kilograms. And I need to elevate the vehicle now, this vehicle, let's say 12 meters. So I'm going to have height, 12 meters. Again, I am creating this problem on the fly. I just want to show you guys the difference between the two energies, 12 meters. And so now I know that I have to find the potential energy because my terms are matching, of course, with this. And I want to find out now the potential energy that the system will gain when it will be elevated against the force of gravity 12 meters from the ground. So my potential energy here, question mark. So how to solve this problem? Well, we know that formula for the potential energy is equal to the mass times the G times the H. And all I have to do is just plug everything in. So it is 1,000 kilograms times 9.80 meter per second square times the height, which is 12 meters. And so we're going to find out now in a moment how much it is, how much potential energy there is equivalent to. So 1,000 times 9.8 times 12. I only got here one significant figures because of this. So my final answer will look like one significant figures. It's going to be 1. Don't need the point here. One significant figure, so it's 1, 10 to the 1, 2, 3, 4, 5 to the 5. Now, what's going on with my units here? I got kilograms times meter over second squared times meter, so that will be kilogram times meter square over second square. So that's nothing else, it's just the joules, unit of joules. And if I need the kilojoules, that will be 1, 10 to the positive 2 kilojoules here. All I just did the conversion here. And again, I already showed you guys in this video how to do the conversion, so I expect you guys can do it. So now, what's the difference now? So the difference here is that once you elevate this vehicle of 1,000 kilograms, 12 meters up in the air from the ground, potentially it can release 100 kilojoules of energy. That's a pretty large energy. And so when it releases energy, I hope you're not standing under this vehicle because guess what? It's going to smash you to death. And that will indicate how much work now this vehicle can do, realizing this potential energy and converting this potential energy eventually to the kinetic energy. And it will produce a certain amount of work here. Again, Now the gravity here will be pulling on the object to produce that work. And that's how you solve these kind of problems on the calculating kinetic versus potential energies.